This is a review of basically of Unit 1. I called it Review Number 1. Um, what we want to do today is review factoring. And factoring is used to simplify rational expressions. So the main patterns you need to know for this course are factoring trinomials where a equals 1, where a does not equal 1, difference of squares, perfect square trinomials, and factoring by grouping. I'll just list the major steps. I won't list all of them. Okay, when we're factoring trinomials where a equals 1, the trinomial has this form, x squared plus bx plus c. And basically, we need, to factor this, we will need two numbers whose sum is b, whose sum is b, and whose product is, and whose product is C. So let's look at this first example over here. Notice we have 4x squared plus 28x plus 48. And you might say, well, hold it a second. A is not 1. However, we can factor out the 4 and make life much more easier on ourselves. So 4x squared divided by 4 is x squared. 28x divided by 4 is 7x. 48 divided by 4 is 12. And now you can see we have a trinomial where a is equal to 1. Now remember, we need two numbers that multiply to give 12 and two numbers that add to give 7. So this is 3 times 4 equals 12. 3 plus 4 equals 7. So we have our numbers. So here we write our brackets. We're going to have two binomials where the first term of each binomial is x, and then we use our numbers here that we found when we're trying to find two numbers that multiply to give us c, right? And two numbers that add together to give us b. So in this case, b equals 7, c equals 12. Now, when factoring trinomials where a does not equal 1, the trinomial will take on this form, and a is not 1. Okay? So that makes things more complicated, but we use the method of decomposition. Use the method of decomposition. Decomposition. Okay? And basically, what we do is we replace the middle term, bx, we're referring to bx, the middle term is bx, and that's when the term is written in this order, right? When we refer to the middle term, we're referring to the linear term of our trinomial. So we replace the middle term bx with two terms whose coefficients have a sum of b and a product of AC. A product of AC. Okay, so let's look at this first one. First, always remember to take out any greatest common factors, because otherwise the question just becomes more difficult if you do not take out the greatest common factors. So I do not note any greatest common factors here. However, we need two numbers whose sum is 7 and whose product is AC. In other words, 6 times negative 5. And that should equal minus 30, because 6 times negative 5 is 30, and we need two coefficients that add up to 7. Well, let's see. Well, let's try 10 and negative 3, 10 and negative 3. Okay, so this is something you'll have to work with through trial and error on your own, but notice 10 plus negative 3 equals b, which is 7. 10 times negative 3 equals negative 30, which is 6 times negative 5 equals negative 30. So I'm going to now decompose that middle term so that our next line will look like this: 6b squared plus 10b minus 3b minus 5. Okay, so notice this is equivalent to this trinomial. These two expressions are equivalent because 10b minus 3b is 7b. So now what I'm going to do is group the first two terms, group the last two terms. We're going to take out the greatest common factor from the first two terms, and that's 2b times b plus 5. And I'm sorry, that should be 3b plus 5. And then we're going to factor out a negative 1. I'm factoring out a negative 1 because I'm going to need a common factor between these two larger terms here, because I want a positive 3b plus 5. So notice, when I look to these two larger expressions here, I see that they have a greatest common factor of 3b plus 5. So now I can factor out the 3b plus 5. And what is left? Oh, this is what's left, 2b minus 1. So if I were to FOIL these expressions, and it's always wise to check your work just by FOILing, 3b times 2b is 6b squared, minus 3b plus 10b is your 7b, and 5 times negative 1 is negative 5. Okay, so using the method of decomposition is more challenging than when a equals 1, and it's a much simpler factoring when a is 1. But when a is not 1, it's a little bit more work. Factoring a difference of squares. A difference of squares has this form: a squared minus b squared. So if you recognize something as a difference of squares, the factoring becomes easy. The pattern to factor is this. The pattern to factor is a squared minus b squared equals a plus b, a minus b. Notice these two binomials are conjugates of each other. They're identical except one has a positive b and one has a negative b. But if I were to FOIL these, I think you would see you would end up with a squared minus b squared. A times a is a squared, minus ab plus ab equals 0. So, and positive b times a negative b equals b squared. So once you recognize that this is, if we look at this example, if you can see that this is a difference of squares, then you know it's very easy to factor. So I can just say, I'm going to just put down my brackets. X plus y is the square root of the first term. Okay? Z is the square root of the last term. One is a plus and one is a minus, and it's done. That's the beauty of difference of squares. If you can see the pattern, it makes your life so much easier. Factoring perfect straight square trinomials. Okay. Now, a perfect square trinomial has this form: a squared plus 2ab plus c squared is equal to, sorry, that should be plus b squared. Let me just correct that. That should be b squared. That equals a plus b squared. Now, the other form of a perfect square trinomial is a squared minus 2ab plus b squared, and that equals a minus b squared. Okay, so if I were to look at a perfect square trinomial, how would I recognize it? So, in a perfect square trinomial, the middle term is equal to 2 times the square root of the first term times the square root of the last term. Okay, so 2 times the square root of the first term. Let me fix that up. I don't like the way that looks. First term. Okay, so if we go 2 times the square root of the first term times the square root of the last term, if we get the middle term, regardless of the sign, we're not worrying about the sign, we will have a perfect square trinomial. If we recognize it as a perfect square trinomial, then it becomes very easy to factor because we know the pattern of a perfect square trinomial. I'm just going to do my rough work down here. Let's just do the test. I want to see if 2 times the square root of the first term times the square root of the last term equals the middle term. Well, we will get 2 times 2x times y. Notice that I get 4xy. Now, I'm not worried about the plus or negative sign as long as I get it, because notice it could be a positive or a negative. We're not worried about that when we're testing to see if it's a perfect trinomial square. So because I know that, I now know, first of all, I can take the square root of the first term and I can take the square root of the last term, and since it equals the middle term regardless of the sign, it's easy to factor. Square root of the first term is 2x. Square root of the last term is y. That's a, oh, it should be, because that's a minus, then this is a minus. And we can check our work. Okay, let's just check. Let's FOIL it just to check. 2x times 2x is 4x squared, minus 2xy minus 2xy equals negative 4xy, and negative times the negative is positive, so negative y times negative y is plus y squared. Good, easy. When you recognize the pattern, it's very easy to follow. Oh, that's the start of classes, so factoring, we'll just ignore that. Factoring by grouping. What we do here, notice there's 4 terms. We can approach this by factoring by grouping. So we group pairs of terms with a common factor. Okay, so if I want to group the first 2 pairs of terms, well, let's see, do they have a common factor? Yes, they have a x squared. So let's do that. X squared times x minus 2. Now, does the next term have a common factor? Well, it looks like we'll use negative 3, and that equals x minus 2. So I will first of all check. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. That checks. Negative 3x. Negative 3 times negative 2 is positive 6. So notice with these 2 larger expressions, I have a greatest common factor of x minus 2, and that leaves me with x squared minus 3. And that's my final answer. I can't factor that any further, so we're done. Okay, now that we know how to factor, we can simplify rational expressions. So the steps to simplify a rational expression is 1, factor the numerator and denominator. Okay? 2, state restrictions. And that's when we want to make sure the denominators do not equal 0 because we cannot divide by 0. And 3, divide by common factors. Simplify. Okay, so let's look at the first one. First we need to factor. Oh, look at the pattern. Perfect square, perfect square. Awesome. Separated by a minus sign. We know it's a difference of squares. So this is x, x. Square root of the first term is x. Square root of the last term is 1. One's a plus, one's a minus. Okay? And now I'm going to, this is a trinomial where a equals 1. Okay? So this is easy to factor. We need two numbers whose product is minus 2. Two numbers that add to 1. Okay? So those two numbers are 2 minus 1, 2 minus 1. So we have x plus 2 times x minus 1. Let's state our restrictions before we start canceling anything out because they're otherwise we don't want to lose any of our restrictions. Notice the denominator would be 0 if x equals minus 2, and the denominator here would be 0 if x equals 1. So x cannot be negative 2, x cannot be 1. Okay, now we can continue simplifying. We'll divide this out, and we get x plus 1 over x plus 2. All right. Uh-oh, they're getting more complicated. But it's basically the same principles as before with maybe a few extra divisions or multiplications. So, to multiply rational expressions, 1, factor the numerators and denominators. 2, state restrictions. 3, divide out common factors. And 4, multiply numerators, whatever numerators and denominators are remaining. Multiply numerators and denominators. Okay, so first we're going to factor. We have a trinomial where a equals 1. So square root of the first term, square root, I'll just put those down. We need two numbers whose sum is equal to 2 and whose product is equal to negative 3. So that will be 3 and negative 1. Positive 3, negative 1. 3, negative 1, 3, negative 1. Again, we have a trinomial where a is equal to 1. We need two numbers that add up to give us 8. And we need two numbers that multiply to give us 16. And that is 4 and 4. So on the denominator we have, actually it's a perfect trinomial square, so it's x plus 4 times x plus 4. Now we keep on factoring. Greatest common factor is 3. And we're just left with x minus 1 on the bottom. Okay, let's state our restrictions. I'll state them down here so it doesn't interflow with the flow of our solution. So x cannot be negative 4, x cannot be 1. Divide out our factors, and we are left with 3 times x plus 3 all over x plus 4. there's our solution. There's nothing more we can do here. We could leave it as 3x plus 9 on the numerator. I don't think that's necessary. Different teachers want different things, but I'm okay if you leave it like that. Okay, dividing rational expressions. Here are the steps. Again, as always, whenever we're simplifying rational expressions, we need to factor the numerators and the denominators. So here we go again. Factor the numerators and the denominators. 2, state restrictions. 3, multiply by the reciprocal of the divisor. 4, add any new restrictions. 5, multiply numerators and denominators of the terms that are remaining. So here we go again. Let's factor. This first one we cannot factor. It's already as simplified as we can get it. Notice the difference of squares. So that's m plus 2, m minus 2. Okay, divided by, well, this is a trinomial where the first term a is equal to 1, and we need two numbers whose product is negative 4, two numbers that add together to give us negative 3. So that would be two numbers that add together to give us negative 3 and negative 4. So that would be negative 4, 1, negative 4, 1. So this is divided by m minus 4, m plus 1, all over. Again, two numbers that multiply to give us 6 and add together to give us 5. So that's 2 and 3. M plus 5. M plus 2, m plus 3. Okay, so let's state the restrictions. M cannot be plus or minus 2. We got the minus 2, minus 3. Let's now multiply by the reciprocal of the divisor. M minus 4, m plus 2, m minus 2 times m plus 2, m plus 3, all over m minus 4, m plus 1. Alrighty. Did we get any more? Oh, look, we have more restrictions because now when we multiply by the reciprocal, we have a new denominator, so m cannot be 4 or negative 1. So usually each restriction on a test or exam is worth half a mark. So now we can divide out. We can divide out our factors that are easy to divide out. And I should add in a step here. Number 5, that should be number 5. Divide out any common factors. Right, let's do that. So it's m plus 2, m plus 2, m minus 4, m minus 4, and we are left with m plus 3 all over m minus 2 and m plus 1. And there are our restrictions. Okay? All right, last one, adding and subtracting rational expressions. Let's see. Number 1, So this was number 5. That should have been step number 6. Okay. Number 1, as always, if you want to add or simplifying any rational expressions, we have to factor numerators and denominators. Number 2, state restrictions. Before you cancel things out, you don't want to lose any restrictions. 3, simplify any rational expressions. To lowest terms. Okay, that will simplify the rest of your calculations. 4, rewrite the expression with the lowest common denominator. With the lowest common denominator. 5, add and subtract as the situation requires. And 6, check to see if further factoring can help you simplify the expression. Check to see if further factoring can simplify the expression. So let's give. So notice step number 1, factor the numerators and denominators. Well, there's nothing in the numerators to factor, but notice the difference of squares. And that should be x minus 1, because when you factor a difference of squares, your binomials are conjugates of each other. Subtract 2 over x plus 1. Oh, that was easy. The factoring was easy. Let's state our restrictions. X cannot be negative 1, x cannot be 1, x cannot be negative 1. So x cannot be plus or minus 1. Okay, so what's our lowest common denominator? Well, we'll write down x plus 1, x minus 1. So we've got what we need in our denominator for the first term. Notice that, we have 2x plus 1 terms here, so we're going to have to add an x plus 1 to this denominator to make sure that this term is covered. Okay, so the easiest way to find out what goes on the top, notice there's an x plus 1, there's an x minus 1. If we multiply the denominator by x plus 1, we have to multiply the numerator by x plus 1 to make it equivalent. Minus, well, we'll write down x plus 1, right? We need that covered. So notice we're missing an x minus 1, so if we multiply the denominator of this term by x minus 1, we have to multiply the numerator by x minus 1. So now we can write everything over x plus 1. We'll just write squared. X plus 1 times x plus 1 is x plus 1 squared times x minus 1. So 1 times x is x, 1 times 1 is 1, minus 2x, a negative times a negative is a positive, and we are left with 3 minus 1 plus 2 is 3, 3 minus x all over x plus 1 squared times x minus 1. Now if I were to look at this, there's no further factoring that will help me simplify this expression. So this is as far as we can go in this question. That's it. That's a basic overview of Unit 1. Again, if you have any, make sure you practice the reviews that you are given. Make sure you go over your tests, and that will help you be ready for your final exam. Take care.